Okay, so WITRIAB, or what is the relationship, if any, between the period of oscillation on the end of this spring and the mass that's been placed on the end. So this is a mass hanger. It has a mass of 50 grams. So the first trial will be, what's the period of oscillation for 50 grams worth of mass? Now, keep in mind the period, once I set this into motion, is the time it takes for the thing to go from the bottom of its travel up and back to the bottom. And as you should know from your reading that you did, it's not real accurate to time just one of these because it's a very short event and the error is relatively large. So use the methods outlined in your reading. I'm not telling you, you're going to have to read to reduce that error. So I'm going to set this into motion and you can do your timing as it moves. All right, that should be plenty. Now the beauty of having a video is you don't need to do, multiple separate trials. You can just rewind the video a little bit and time again and get some multiple trials to reduce your errors. So that was 50 grams of mass. The next is going to be 100 grams of mass. So that should be sufficient. The next is going to be 200 grams of mass. Alright, now we'll double the mass again. Because notice I've been doubling the mass each time. I did 50, 100, and then 200, and now we're going to 400 grams of mass. Something you should kind of ask yourself after you graph this, it's clear that the period is getting larger. Is doubling the mass doubling the period? Is quadrupling the mass from the original value quadrupling the period? That sort of thing. Think proportionally here. Is this increasing steadily or is it not maybe increasing so steadily? So here's 400 grams. And the last trial is going to be 800 grams. So once again, I'm going to double the mass. Okay, should be all the data you need.